Let's start with the topic of viscosity. If we just talk about basic definition of viscosity, we can write that it is the property of a fluid due to its intermolecular forces. By which, in case of fluid flow, the relative motion between layers of fluid is opposed. It is similar to that of friction which we have studied in case of dynamics. Like say if on a ground, if a body of mass m is placed and say if the ground is rough, and if the body is moving with respect to the rough surface, then the surface has the tendency to oppose the motion. This is the friction which is acting on the body in the opposite direction to the motion, and according to the Newton's third law on the ground it will act in forward direction. Similar to this, if we talk about the flow of a fluid, say on a surface of ground, say, there is a liquid which is flowing. We can say there are different layers of fluids which are moving relative to each other because there exists some friction between the layers of these fluids, due to their intermolecular forces. If we consider several layers, we can see in this situation at the bottommost layer the whole weight of fluid is acting, so the friction acting on the bottommost layer will be maximum. As we move up, the friction on the layers will decrease because the weight of fluid, which is applying some normal reaction on the layer, will be less. So at a height y, if we consider a small layer which is of width dy, we can say if just below the layer the fluid layer is moving with velocity v, then certainly we can say the upper layer will be moving with the speed v plus dv, because on lower layer the friction is more and on upper layer the friction will be slightly less, so this will be having slightly more speed. This we can experience practically if we just flow water on ground, or any liquid on rough surface. Then in that case we can observe that the topmost layer of the liquid or water will flow faster as compared to the lower layer of fluid, because lower layer will experience more friction. Now if we talk about these two layers 1 and 2, we can see this one is moving faster with respect to 2. So this one will be experiencing a friction force in backward direction, which we term as viscous force, which is termed as Fv. On the lower surface or the lower layer it will act in forward direction. Similarly on the upper layer it will act in backward direction, and on this it will act in forward direction. But the force which is acting in lower surface of this layer will be more than the upper force, so the net force acting on it in backward direction is denoted as Fv, or viscous force. If we talk about this viscous force, experimentally it was obtained that there are several factors on which the viscous force depends that we can write. It is found that viscous force on a fluid layer mainly depends on two factors. First is, this viscous force is directly proportional to the area of this layer, which we can write surface area of layer. If the layer's surface area is large, the viscous friction will be more because of more intermolecular interaction between the layers. The second is, this viscous force is directly proportional to velocity gradient, which is dv over dy, that is over a layer of width dy. If the change in speed is dv, then in this situation this dv by dy is termed as velocity gradient of layer. So this depends on these two factors. If we combine these, we get a proportionality constant. Let's continue this on next slide. Now from these 2 points on which this viscous force depends, we can write Viscous force on fluid layer is, this can be written as Fv is equal to, put a proportionality constant eta A dV over dy. More precisely, as viscous force act opposite to the direction of motion, we must include a negative sign here. We are denoting it vectorially. Here this, eta, is the constant of proportionality, which depends on the intermolecular properties of the liquid, and this is the constant of proportionality called coefficient of viscosity. This coefficient, we can write that it depends on intermolecular properties of the fluid. So just remember that this is the expression for the viscous force acting on a fluid layer in which fluid is flowing, which is having a velocity gradient dV over dy, and the surface area A, and if the fluid has the viscosity coefficient, eta, then it is given as its magnitude is eta A dV over dy. We will see different applications related to this.